everyone, welcome back to my channel. Today we are diving into an awesome concept in deep learning, that is feature extraction using transfer learning. Now don't let the big words scare you. I will break everything down into super simple terms. So let's get started. So exactly what is transfer learning? Transfer learning means we will be using a pre-trained model into new problems for solving them. So this topic sounds technical, but it's basically a smart shortcut in AI. Instead of teaching a model everything from scratch, we reuse the knowledge of an already trained model to solve new problems, like borrowing someone's notes for an exam. So feature extraction using transfer learning in neural networks leverages pre-trained models to extract meaningful features from new input data. So we take a pre-trained model, a model that's already learned from a huge dataset, and use it to pull out meaningful patterns or features from new data. In simple terms, features are important parts of an image like edges, shapes, or textures. Things model notices, and transfer learning is like using someone else's experience to help you get better at something faster. So, why is this useful? The purpose of it. These features are high-level representations that can be used for tasks like classification, clustering, etc. Its benefits are it reduces the need for large labeled datasets and training. It will also save time, and we get smarter results with less work. The one more benefit we have is it will reduce overfitting. So, what is overfitting? It will reduce the extra over learned models, and since it will reduce the overfitting, it will just have the important things that are necessary. So here in this diagram we can see that uh, this is the diagram process which shows the process of reducing the unnecessary data. So this is the original data which has many features and many labeled datasets. So, and these are the new features, reduced data. In this, we have only necessary data which will be used in the model, and by this, the only transferring will be done. So let's move ahead and look at the steps to perform this feature extraction. So the first step in this is select a pre-trained model. So to do this, start with a CNN. CNN, as we know, a convolutional neural network, which is used for image recognitions. It uh, takes like image edges and shapes, colors, and all. So these are already trained on a massive datasets like ImageNet. Models like VGG, ResNet, or Inception are popular choices. So VGG is used for image classification and feature extraction. ResNet is a residual network, which means that it is used for again image classification, detection, and inception, which is also used for this. So these are the popular choices. In simple explanation, think of these pre-trained models like chefs who have mastered cooking. Now you just ask them to help with a part of your new recipe. So now the next step is remove the top layers. So remove final classification layers from the pre-trained model. Retain initial layers that extract generic features like edges, textures, shapes. This makes the model act as a feature extractor. So these top layers are built to recognize specific things like dogs or cars. We remove them and keep the early layers that recognize basic patterns like lines, curves, and colors. Okay, so now let's move the next step, that is feature extraction, the main thing. So in this now we feed our new data into this trimmed down model and grab the output from one of the middle layers. This output is a compact summary of the important features of the input. So in simple analogy, imagine running a photo through an X-ray machine and getting a cool blueprint of what's inside, not the final decision, just the data. So now the next step, that is dimensionality reduction. So in this sometimes the extracted features are too many. We use tools like PCA to reduce them without losing important info, like we had seen in this diagram, that reducing the features will also help in reducing the overfitting. So this all is done using tools like PCA. So now, so it's like summarizing a long article into bullet points, smaller but still meaningful. Now the next step is train a new classifier. We now train a small model like an SVM, support vector machine, logistic regression, or a mini neural net using the features we extracted. In short, we are teaching a new model to make decisions based on the smart info we just extracted. Next step is optional, but it won't hurt to do this step. It's the sixth step is fine tuning. Optionally retrain some layers of the pre-trained model. Adjust the model weights slightly to better suit the new task. Improves performance further but requires more resources. If we needed, we can tweak or retrain some layers of the original model to better fit our specific task. It's like customizing a suit you brought off the rack so it fits you perfectly. Now, the last step is evaluation and testing. So, we test the final model on some test data, adjust some settings called hyperparameters, and measure performance using accuracy or F1 score. So, accuracy is how often we are right, and F1 score balances being right and not missing anything important. And what are the applications? So, medical imaging, object detection, natural language processing, and facial recognition. So, in real life, we use in all of these applications. Object detection means spotting items in security cameras, and in medical imaging, detecting diseases from X rays or MRIs. And in natural processing, understanding and processing text or speech. So, to sum it up, feature extraction using transfer learning is like reusing a genius model's brain to speed up our own learning. It's smart, efficient, and super powerful for real world AI tasks. Thank you.